Mayor again. Thank you all for having me today, and you know who I am. Probably, I'm that guy who bans people on Discord for asking for free stuff. But really, I'm just a guy started about 6 months ago in the pen testing side, and really just jumped in with both feet. So uh, we're going to take a really high overview today with what we're talking about with Ruby buffer overflow exploitation. So typically, as either a new or even an intermediate uh, pen tester, when you're looking at buffer overflows, people typically think Python. And you're thinking Python because it's pretty simple. You've seen a video before. Maybe you had the practical ethical hacking course. And you see that things like Vuln server are built around, the guides you see are built around using Python. Going through the PTP course before I got my ECPPT certificate, there was a section for Ruby buffer overflow exploitation in the elite version. And going through that just really clicked for me a lot more than Python did. And it's very much inclusive. It keeps the entire process all in one house. So we're going to show you a way today to work completely through Ruby with your buffer overflow. We already do a lot with Ruby. If you're talking about pattern create and pattern offset, you're talking about MSF Venom and MSF console. So there's a lot of integration already with Ruby, but we're going to push it a bit farther and show you how to fuzz with Ruby through the IDE, how to use a Ruby boilerplate, so to speak, with your exploit, and how to exploit the machine itself with using Ruby versus using Python. So again, really high overview, not a whole lot we can cover in 30 minutes, so we're going to do our best. We're going to briefly touch on how we can enumerate and what to expect if you're trying to enumerate a service that you think is vulnerable to buffer overflow vulnerabilities. We're going to talk about that Ruby exploit development and the exploitation as well. I do have some resources here for you guys. I shared the link for this. I put today's PowerPoint on GitHub there. The link is there as well as in the chat. I also have my buffer overflow exploitation boilerplates on GitHub in that first link. I was going to run the Gatekeeper lab that I built over on TryHackMe. I'm just going to do a little bit locally instead on the same exact machine, just what I have here in my lab. So additionally, if you want to get the EXE itself, it's at DoStack Buffer Overflow Good there. It's by a guy named Justin Stephen. He deserves a ton of credit for this. It's an incredibly good vulnerable program. So a 100,000 foot overview, right? And just right off the top, I'm not an expert at buffer overflow exploitation. I'm going to talk from my perspective. If I'm wrong about something, please pipe out, please chime in and say, hey, you're getting this wrong, dude. But for the most part, when you think about your buffer overflow, you're thinking about a program written in any number of languages, but we're really thinking for this, we're thinking C or C++, because that's where a lot of the vulnerable functions are going to be. And just as an example, when you go to fill out a form online or a form in a program and you're using data input and you're saying, hey, you need to put in your last name. So here on the screen, you see last name, you see Helle, that's my last name, and there's 6 boxes there. So we're going to pretend that each one of those boxes has a 4-byte allowance or that they're worth 4 bytes each. So you see that I've got 20 bytes in total of text out of 24 available. This buffer would not be overflowed. However, if we look at this one and we use the name Simpson, we have last name, we have Simpson. Unfortunately, we have a 24-byte buffer or input allowance, and we're trying to input 28 bytes. Those additional 4 bytes have to go somewhere. And if it hasn't been programmed to specifically eliminate them or allow extra room in memory to be allocated, those extra bytes have to do something. They have to go somewhere. They don't just disappear. And that's where, when we talk about buffer overflow exploitation or vulnerabilities, that's where our vulnerability is coming from. When that input isn't being sanitized properly to deal with those excess bytes. So we're talking about different functions that are vulnerable, and we've got them here on the screen. You got printf, sprintf, strcat, strcopy, and gets are many of the those are the the prime candidates for your vulnerable functions. We got a little bit here on the right side of the screen. This is actually from DoStack Buffer Overflow Good. This is part of the code from the program itself. In programming, these should be considered unsafe and they should be avoided. And there are alternatives available. We're not going to get into that today. That's a bit out of the scope of what we're covering. But if you do a bit of C or C++ programming, certainly know that these are vulnerable functions and that you really should avoid them. Also, if you guys have any questions along the way, please stop me. I'm a windbag and I talk a lot. So if I'm going too fast, if I'm going too slow, just let me know. If you're going up against a lab environment or a live target and you're running that Nmap scan, sometimes you're going to get feedback from that service that's running that may look weird. And in this case, this is on port 31337, which is the vulnerable port for the executable we're looking at today. And you're going to get a lot of different feedback. This is coming from the Nmap probe that's going out, and this is the program talking back. So if you see something like this in your Nmap scan, start wondering that there's maybe a program or a service there that's running. It's not necessarily vulnerable, but it does warrant and merit additional enumeration, and you should look at it some more. Just kind of, this is just an intro leading into where we're getting. So now we're going to start talking about Ruby. So Pry is an IDE-like Ruby environment that can be used to interact with programs, much like your Python IDE or other development environments. It's available in the app repository on Kali. You can interact with it and open and interact with TCP sockets. You can see a picture of that here on the screen. And it's good for fuzzing quicker than modifying files, like if you would use TCP spike, like you would expect to do using Python for buffer overflow exploitation. So we're going to show you how to do that here in just a minute. I'm going to see if I can figure out how to switch the screen here quick. And we're going to pop over here to, can you guys see my Kali, my Windows machine here?
Yep.
Okay, so on the left we have my Kali machine. On the right I've already got Gatekeeper running. This is the do stack buffer overflow program, just running with the Gatekeeper name. That's what I used in the Gatekeeper machine. And so you see it's already listening for connections. So if you want to open up the Pry developer environment, I like to use Pry tac simple tac prompt. And it just gives you this simple environment here. So I'm going to push up a couple times. And you can see syntax here for trying to connect via TCP sockets. So essentially what we're doing here is we're reaching out and connecting to it. You see this with your Python boilerplate when you are doing your exploit development with when you're writing out your exploit itself. The same thing down here we're seeing if we look at this right here with the boilerplate exploit that we're going to cover here in a little bit. We're doing essentially the same thing. We're just doing it through the developer environment. And this is going to allow us to fuzz the program manually versus just sending it out with an automated tool. And it gives us a bit more granular control with what we're trying to do. So if we hit enter, on the left, you see that we get green. Green is always good when you're talking about Pry. We were able to connect, and here on the right, you get the confirmation. We see that a received connection from remote host, and it's been handed off to the handler thread. So that's internal operations within the program itself. And now if we want to shoot some bytes to it, all we have to do is use the sputs command. So we're going to do sputs, and we can just do A. We'll send 50, and you can see that 51 bytes were received, and we got nil back. So the program didn't crash, but it communicated with it. I think we can do it again, and we can do this all day. Now, if we want to try to crash the program, if we want to fuzz it to see if it's vulnerable to buffer overflow, we could send, say, 500 bytes at it. And you're going to see send failed. If we try to connect again, we're going to get nil. If we try to connect, it's not going to actually connect. The program is crashed. So when we're talking about this at this point, if you've ever done anything, Rum, I think you said you were an FO. So you know what it's like to walk in fire. And we do the same thing here at this point when you're talking about trying to figure out or get as close as you can to where that offset is going to be. And we can do that with Pry. So if we know that we're at 500 bytes right now, we can connect again and we could send half of that. So we can send 250 bytes, right? And it's going to crash. So now we're manually fuzzing. We're going to cut in half every time until we no longer crash it. And then we're going to add more bytes until we crash it again and walk back and forth until we get close to it. So we'll start this one more time, just kind of show you that effect when we cut it in half. It won't crash next time because of the value of the offset in general. So we're going to start one more time. We're going to connect again. And instead of 250, we'll do 125. And you'll see that we don't have enough bytes now. So we can 50 bytes, and I'm going to tell you the program will crash again. In full disclosure, it's at 146. So we can use pry back and forth instead of just sending random amounts of characters or bytes out using like TCP fuzz or the generic TCP send. We can do this individually with our own commands. And again, it gives us a bit more control over the process versus just running a program and trying to pick through the results to say, hey, you know what, this thing finally crashed at 6,000 bytes or 175 bytes or 350 bytes. And that's one of the benefits that I see of pry over using like TCP generic send. So we're going to switch back over to the PowerPoint really quick and continue moving along. So again, we talked about fuzzing here. We're using the walk it in processor technique at that point to try to get closer to that offset. And then we start moving into developing the exploits. So if we were to crash our program, which we did, and we send enough of those A characters or those A bytes, we see that our EIP here is 41414141. So now we're getting back into our expected territory with what we're talking about with buffer overflows. But now we start going back and looking more at additional Ruby tools. We're talking about using pattern offset, pattern create, which are Ruby tools, which allows us to keep it all under one house, I guess. But really the value of this PowerPoint is the pry part and the boilerplate part. So we're going to cruise through the offset part a little bit and the pattern create, assuming that you guys have probably done this before. But again, we're utilizing create and offset. We're getting that offset value so that we can determine where our EIP or where our buffer is going to end and where our EIP is going to start for takeover. We've done that here. We've utilized those tools. We find after adding those junk B characters that we get the 42 times 4. And we're able to start building out then what our Ruby buffer overflow boilerplate is going to be. And again, we touched on our boilerplate briefly. It's no different than your Python boilerplate, just in a different language. And it just looks a little bit different. So moving forward, again, we're talking about that. It's a common term in web development and programming, your boilerplate. I use a default one from the start to the end. I title it out so I know what goes where. And it really just provides a bit of ease of development for our exploit. In this case, I've provided you guys the boilerplate and the link in the PowerPoint. It's on my GitHub for everybody to use as you wish. So I've done the easy, or I've done the hard work for you already. All you have to do from here on out is input those values. And then moving forward, we need to start thinking about what our bad characters are going to be. So when we talk about our exploit development, we're always going to have the challenge of bad characters. What is the interpreter that we're running the program through going to see as good or bad characters with our shellcode? And our shellcode is going to be what our instruction is to the machine, and it's going to be in a language that the machine understands. So these are characters that interact negatively with our later shellcoding, and the null byte, the X00 byte, is something that we're always going to want to exclude at the basic level. Now at advanced levels, you may want to use it. But at this point and where we're at right now, it's not something we're going to want to utilize. So we can use pry to do this, or we can use our Ruby buffer overflow boilerplate. I personally just go straight for the pry value. It's a bit easier. You just send it out with your A characters. So your A times 146, your B times 4, and then your bad characters. And when we get that, then we come back in and we can manually or automated do an automated check to see what those bad characters are going to be. So in this case, you see, we right click on the ESP, that's our stack pointer. We're going to follow in the dump, and over here we get bad characters, and we can see that it starts at our 41s, that's our A's, running all the way through what that buffer is that we determined. And then we've got our 4B characters here that you see with the 42s. And then we go through that hex dump and find any characters or any bytes that are out of place. Now, when you're talking about do stack buffer overflow good, the null byte, the X00, is going to be bad, and the 0A is going to be bad. And that's really hard to find on this one unless you look right down here at the bottom. This should be a 00 if it was working correctly, but in this case, that byte's out of place. So we start looking at developing our exploit from here. Again, we've got our offset already. We know that we need some B characters there, so we have our NOP sled set, and then we need to determine what our hijack command or our call or jump ESP is going to be. And this is about the only time we're going to use Python through this entire process. If you're using monomodules, monomodules is a Python process or a Python module. So we're going to use the monomodules command to see if we can find an exe. We're going to find that gatekeeper exe. Additionally, we're going to try to find a jump or a call ESP that we can hijack to use as our instruction pointer to point onto the stack or to point at our shell code. And we're going to do that, and then we're going to add that EIP value, as you see here, into our shell code or into our exploit on our Ruby buffer overflow boilerplate. So continuing on then, we're going to output our shell code into Ruby. And we use that or do that with our format RB flag right here, as you can see. So the shell code is the machine readable command that allows us to instruct the machine to execute the commands we want to issue. It could be popping a calculator, it could be popping a shell, it could be changing user permissions, it could be shutting down the system, it could be making registry edits. All kinds of things can be done via shell coding. It does very much depend on what the permissions are of the user. So if the user who owns the system is simply a low-level user, you're probably not going to be able to change registry or disable a firewall, but you might be able to get a reverse shell under that user. And again, MSF Venom is primarily used for shellcode generation, and we're using Ruby at this point as well. So once we have obtained our shellcode through our MSF Venom command, it's added to our exploit, right? So you can see a full example at that point of our exploit minus the TCP socket opening at the end. And the format's similar, to if you were using Python. You just don't have that variable in front of each line. So even if I do Python, exploitation, I'm still going to use the Ruby outputs. I just think it's cleaner. But you can use Python here as well. Your output doesn't matter so much as long as it's consistent. So if you have buff plus equals, you need to have your Python output needs to be buff plus equals throughout as well. And again, we're talking about our shellcode here. So your buffer overflow has to have, it's going to come after the NOP sled. Typically, your more advanced buffer overflow exploitation or vulnerabilities are going to require shell coding that may point at other shell code, may point at other vulnerabilities or other commands, and it could jump around a few times. Well outside of the scope of this course, I know Rumham was looking at like the XDS course, I think on eLearn security. You're talking more advanced exploit development at that point where you're going to be doing these things. And from here on out, we're using Ruby just to fire off that exploit itself. So once it's developed, we want to test it locally first. A successful test locally does not mean you're going to get a successful test remotely, especially if you're looking where your protections, your ASLR protections, for instance, are not consistent. And that's where finding that vulnerable program or DLL is going to be really important that we showed you a little bit ago. So we're going to fire that off using Ruby. You do see an example here. We use the Ruby RBOF boiler.rb to fire that off. We do get the reverse shell as expected. But again, it's not something that's always going to work. And I can tell anybody who's taken the PTP exam before knows exactly what I'm talking about. Or if you're going to take it, know that just because it works locally, you could still have a lot of work to do. Beyond that. Additionally, when you're talking about your shells, you want to think about ports that might be open. If you're trying to evade or you have to go around firewalls, 1080p earlier was talking about ports that are typically or commonly going to be open, your 80s, your 443s. Those are ports that you're going to expect to be open and usable. So you might want to consider your shell coding to reflect with your listening host or your local host port to be one of those if necessary and if possible. And again, our exploitation comes through here at this point. And we covered our user and our admin access. So if you're a user level, if you're a low priv user, you're going to get low priv access with reverse shell. You're going to get low priv privileges. So you may not be able to do user creation or password modification, etc. And outside of that, I didn't expect it to go that fast. My apologies. But I would be happy to have any questions. We can show off some more here on the other screen if you want to see any additional commands thrown at any of these. I'm happy to entertain any of that.
Hey, thank you very much. I appreciate you going through this. I haven't seen this done in Ruby yet, so I was really interested in that. So went
It's my
really
pleasure.
well. And um, I just wanted to also kind of throw something in there. The mayor has his Twitch link there. If you guys aren't watching the mayor on Twitch, you're missing out. You're gonna learn something new. You're gonna have a good time chatting with people. Um, and it's always just a good time just hanging out. So definitely start watching the mayor on Twitch.
Thanks for the plug, man.
Yeah, man, I really enjoy that. I mean, I wouldn't throw that out there if I didn't enjoy them. So yeah,
Sure.
absolutely.
Thanks. Does anyone else have any questions or comments? I'm happy to entertain anything at all. Awesome. Okay. Well, thank you so much for having me from many states away. I do appreciate the invitation today, so thank you so much for that, and let me watch some of the other presentations. They were really, really good. So 1080p, I love my Raspberry Pis, and I was just enamored by everything you were doing. So good on you, man.